All right, welcome back. We're going to talk about percent composition today. That's our first topic in Unit 3. Percent composition is really all about finding percents. And usually when you find a percent, you take the part you're interested in, divide it by the whole, and then multiply it by 100. And that's how you get a percent of anything. So if we wanted to find out what percent or what your percent was on the test you just took, you would take the points you got divided by the total points and multiply it by 100. Percent composition is very similar to that. It is the percent by mass of each element in a compound. So what we're going to do here, let me take you through a couple examples of, for instance, if you want to find the percent composition of water, right? First thing you're going to need to do is always to know what the formula is. So formula for water is H2O. That's important to know because we have to know how many hydrogens and oxygen and so are in our formula. So according to our little process here, find the molar mass of the compound. So we're going to do that first. Molar mass of water, we're going to take 2 hydrogens and an oxygen. We're going to add that together. So you look on your periodic table, the one we gave you, and it's 1.008 for hydrogen. So you need 2 times that plus the molar mass of oxygen. You add that up, you get 18.02 grams per mole, right? We're going to round to the hundreds because of sig figs. Second thing we do is we need to find the mass of each element in the compound. To go back to the formula and we say, well, hey, we have 2 hydrogens, right? So 2 times 1.008, hey, that's 2.016 grams per mole. And then oxygen, hey, that's really easy. It's just 16.00 grams per mole, right? So then we want to actually find the percent composition. You have to do this for each element in the formula. We're going to do what percent is hydrogen and what percent is oxygen. So we take the mass of each element. So we divide the number of, or the mass of each element divided by the molar mass. So we're going to take our 2.016 grams divided by the total 18.02. We're going to multiply that by 100. I'm going to grab a calculator here. 2.016 divided by 18.02, and then multiply it by 100, and you get 11.19%. Let me make sure I typed it in correct. 2.016 divided by 18.02. No, it's 11. Yeah, there we go. 11.919%. Okay. Now, some of you are thinking, well, if the rest of it is oxygen, can I just subtract from 100? Absolutely. But sometimes there's more than one or more than 2 elements. So let's just go ahead and do the math. You take your 16 divided by 18.02 times 100. So calculator 16.00 divided by 18.02 times 100, you get 88.79%, right? And it should come up to a total of 100% or within maybe a tenth. Sometimes it has to do with rounding that makes it an issue. But that is how you find the percent composition by each element. And let me run you through one more example. Let's talk about ammonium carbonate. So the tricky part with ammonium carbonate is you definitely have to have a good formula, right? So if we're thinking, okay, ammonia is NH4 1+, and you should know that, and then carbonate is CO3 2-, then that means in order to get those charges to balance, we're going to have 2 of the ammonium ions, right? So NH4 parentheses 2, and then that will balance out with our carbonate, right? Now that we have a good formula, we can, step 1, find the molar mass. In order to get the molar mass, and again, you don't have to maybe write this first line that I'm doing to get the molar mass, but to kind of look at everything, we actually in our formula have 2 nitrogens, right? Because if we were to multiply through, we have 2 nitrogens and 8 hydrogens. We have a carbon, and then we have a total of 3 oxygens, right? So that's essentially how we're going to find molar mass. I'm going to keep going along this line. 2 times, you look up the molar mass of nitrogen, which is 14.01, right? and then 8 times the molar mass of hydrogen. Hydrogen's 1.008. Then you have carbon, which is 12.01, and then you have 3 oxygens, which are 16 apiece. So then you grab a calculator, and I'm going to go with all of these numbers, add them all up. Plus 2. I get 96.09. I'm only going to go to the hundreds grams per mole, right? So that's step 1. Second step is I'm going to get the mass of each element. So I know for nitrogen, it's just 2 times 14.01. So there we go, 28.02. For hydrogen, it's 8 times that number, right? So 8 times 1.008. That's going to give me 8 times 1.008. You get 8.064. Oxygen is going to be, I'm kind of doing this. I guess I should, let me go with carbon next. Let me erase that. There we go. Let's go back. Let's do carbon next. Carbon's just 12.01. And then oxygen is going to be 3 times 16. I can do that math in my head. That's 48.00, right? And these would all be grams, right? So then when we go to do our percent composition, we've got to do for each element, percent nitrogen is going to be 28.02 divided by 96.09 times 100. So 28.02 divided by 96.09. And then we're going to multiply it by 100 because we need percents. So 29.16%. Percent hydrogen is going to be this 8.064 divided by 96.09 times 100. So 8.064. My lights go out in my room. There we go. 8.064 divided by 96.09 times 100. You get 8.392. We're going to go for sig figs on these. Percent carbon is just 12.01 divided by this 96.09 times 100. So 12.01 divided by 96.09 times 100. You get 12.50. And then last but not least, percent oxygen. You're going to go with our 48 divided by 96.09 times 100. And again, it should be the difference. If we were to add all these up, 48 divided by 96.09, you get times 100, you get 49.95%. And if we were to add all of these percents, I'm going to do that real quickly. I get 100.005%. There's a little rounding going on here, but this is exactly how you do this. Remember, you have to do the percent of every single element in the formula. Okay? Let me go over one more type of problem that comes up, and this will probably show up on a test for dealing with percent composition. Which compound of these 4 listed here has the highest percent by mass of oxygen? So I'm going to kind of do a little bit, excuse me, faster process here. To get the percent oxygen, I'm basically going to look at this formula on A and I say, well, I only have 1 oxygen. So that's 16 divided by my total. And I would kind of do the math out to the side. I have 2 hydrogens, 1.008 times 2 plus 16. Hey, we already dealt with that, 18.02. If we really wanted to get a percent, we would do 16 divided by 18.02 times 100. And you would end up with, after we do times 100, 88.79%. But I'm going to tell you, if you have a question like this, you might as well just keep the number in the calculator, that 0.8879, because that'll just simplify our process. We go on to the next one. For letter B, we have 4 oxygen. If you do the math on that, 16 times 4 is 64. And I'm going to kind of shorten things here. I'm not going to worry about the decimals. If I look up sulfur, I'm dealing with 32.07 plus my 64 for the 4 oxygen, plus if I look at sodium on the periodic table, 22.99, I'm just going to call it 23, and I'm going to do that twice. And I'm just going to round this to 142. We're just doing some quick math here. If I take 64 divided by 142, I get 0.4507. That is definitely smaller. And if I turn that to a percent, that's only 45%. So it's not that answer, right? I'm going to do the same thing with the rest of these. I have 3 oxygen on the third one. 3 times 16 is 48 divided by, I'm going to take that 48 for the oxygen plus 12 for carbon, just going to round it, plus when I look up calcium, I get 40.08. I'm just going to say, hey, that's just like 48 out of 100. Hey, that's 0.48 or 48%. That one's less also. Move on to the last one. You have 2 oxygen. 2 times 16 is 32 divided by the total. 32 plus, I have 4 hydrogens. Just going to add 4 plus 24 for my 2 carbons, 32 out of 60. You can probably tell already by looking at that, that is smaller also. That's a little bit higher than the other 2, but that is the smallest. So what you're looking for, highest percent by a particular element. Yes, you want to look at the numbers of that element in the formula. We also want to look at it relative to the total molar mass of that compound. That 16 is a much higher percent out of the total because the molar mass of water is pretty low. All right, thanks.